The functions. The set of first elements of a relation is its domain. So again, we're getting a lot of terminology that you're going to have to learn. So the domain is considered the input, okay, of the function. The set of related second elements of a function is its range, and that is the output. So here's another definition here, and then I'll go over it. A function is a special type of relation where each element in the domain is associated with exactly one element in the range. And so you'll see the definition for function. For every input, there's only one output. So you got to think of, I pretend my smartboard is a function machine. And so something goes into the function machine, and then you get the output, okay? So if it's considered a function, when you put something in, like for instance, say I put this pen in, I'm just making this up. A function is a function because I know for sure what's going to come back out. Maybe an eraser will come back out. Some formula transpires it into something else, or what, right? But if it's not a function, if the pen, I'm going to say, I don't know, something else goes in, and it's not a function, then I have no idea what's going to come back out. So whenever you're unsure if something is a function, ask yourself, am I sure whatever I put in, I'll get the for sure thing out that I'm supposed to get? Okay, so it takes a little bit of practice or whatever. By the way, when we're talking about a table of values or a set of ordered pairs, I hope everybody knows that x comes before y in an ordered pair. Okay? How do I remember this? You might remember it alphabetically. I don't know. How do you remember which one comes first? You just know? Okay. So because domain is the input, x is the input. Does everybody see that? X goes in and your y value goes out. Do you remember doing this in grade 9 when you were graphing lines and stuff? You picked, say you picked 0, 1, 2 for your x's. It went into the equation, and then you got your y values from it, and then you plotted it and connected the dots and got a line out of it or something like that. Yeah? Okay. So domain is your x, the input. Range is the output or the y's. Okay? How do I remember which one's which? It's alphabetical. Domain, range, alphabetical. Pretty easy, right? Okay, so for each relation, we have to identify its domain, range, and decide whether the relation is a function. Okay, so here is a relation that associates 5 foods to the food groups to which they belong. So orange, fruit, cheese, dairy, broccoli, vegetable, milk, dairy, kiwi, fruit. Okay, so what is my domain? So we write the domain like this. Who can tell me the domain? Yeah, orange. Cheese, yeah, it's all of the first ones of the thing. Broccoli, very good. Milk. Kiwi. Okay, and my range. What's my range? Range is the output. So, fruit, dairy, vegetable, dairy, fruit. Okay, so now the question is this a function? So you got to ask yourself, if orange goes into this machine here, do you know for sure what's going to come out? Is that a yes or no? Yeah, we're going to get fruit, right? How about cheese? Dairy, broccoli, milk, dairy, kiwi. So this is a function. Okay. Now we're going to look at B here. So this is the number of players on a team for various sports here. Okay. Yes? This is a directional. So the input is 5. The input is 6. The input is 9. The input is 11. Then we get various things coming out, right? Okay. So what's my domain? 5, 6, 9, 11. Okay? What's my range? Baseball, basketball, hockey, soccer, volleyball. Okay. Now for the kicker. Is this a function or not? And what do you think? So, the question there lies is, if 5 goes into this machine, what would come out? Basketball, right? Good so far. It's a function so far, right? Because I knew for sure basketball will come out. What about when 6 goes in? Not sure what's going to come out, do you? You don't know if it's going to be hockey or volleyball that's going to come out. So guess what? Right there, it fails the function test. It's not a function. Remember, the definition of a function is for every input, there's only one output. And so when 6 goes in, that's the input, there's 2 possible outputs. So that means it is not a function. So right here, not a function. Okay. This is going to take a little bit to tell whether something's a function or not. So don't worry. Okay. Let's do the next one here. Looks like various instruments, and then is in the key of. Okay, so let's do our domain. Our domain is alto sax, clarinet. Remember, domain is the input, the first thing, right? Clarinet, French horn, piano, trombone. Okay, and then my range is what does the B and the little b mean? Who's the music? Huh? B flat. C, E flat, and F. Okay. Is this a function? Does anybody say no?
No.
You don't think it's...
No, because like 2 things away.
Okay, so remember my definition of a function is if something goes in, I know for sure what's going to come out no matter what. Okay, so, yeah, see, this is where you have to really... Okay, so alto sax goes in, for sure I know it's E flat. Good so far, right? Clarinet goes in, for sure I get B flat. French horn goes in, for sure I know it's an F. Piano goes in, for sure I know it's a C. And trombone, for sure I know it's B flat. So, guess what? It's a function. Yes, it is a function. Okay. Okay. This table shows the masses of different number of Canadian quarters. So they're saying this is the independent variable, the number of quarters, and the mass is the dependent. Well, that should make sense to you, that the mass depends on the number of quarters there are, right? It's not the other way around. And of course, the input is the domain, the number of quarters, and the range is the mass. The mass of quarters m depends on the number of quarters n. So we say m is the, which variable? Dependent or independent? Dependent variable, and n is the independent. Sometimes people have trouble understanding which one's which. Remember, if it's dependent, that will be your output, because it depends on what goes in, right? Okay, all these things are kind of coming together now, hopefully. Okay, describing functions. This table shows a sample cost for a pay-as-you-go cell plan. So the number of minutes, 10, it costs $2, 24, et cetera, et cetera. So a table of values usually represents a sample of ordered pairs in a relation. So, is this also a function? Is this a function? Yep. Yes, it is a function. Any questions on whether it's a function or not? So if 10 minutes go in, I know it's going to cost $2. There's no question about it at all. If I have a cell plan of 20 minutes, I know for sure it's going to cost $4. There's no doubt about anything, right? Okay. Identify the dependent, independent variable. Okay, so which one is the dependent variable? Yeah, so the cost. See? And the independent is number of minutes, and that would be n. Okay, yeah, I guess why is this relation also a function? The best guaranteed 100% answer is for every input, there is only one output. So if I ever ask that question on a test, write that verbiage. For every input, there's only one output. And if it's not a function, just say for this input, there was 2 outputs, so it didn't work. I'm not sure what the answer is or whatever. Okay, so domain, range. Practice those brackets there. What's my domain here? What's my domain? Yeah, 10, 20, 30, 40, 50. And my range is 2, 4, 6, 8, 10. Okay, any questions there? Easy so far? Okay. We can write an equation that represents a function using functional notation. For example, c equals 15 plus 2n represents a function. We write it as c, and this is how you pronounce it also. C of n equals 15 plus 2n. Okay? Some people get confused. They think it's c, and then they see brackets. They think it's times, but it's a notation. This means c of n. Okay? And n represents the input. That's why it's inside the brackets. So n is the input, and this is c of n. So this notation shows c is the dependent variable, and n is that c depends on n. Okay? So Carmen works for a research company in a shopping mall. The equation P equals 5n plus 30 represents her daily pay, P dollars, when she conducts n surveys. Describe the function. Describe the function. So describe means words, so we got to use words. So, can anybody describe what's going on here with this equation? Well, what does the 30 represent there? For instance, if she does no surveys at all, how much does she get paid? 30 bucks. So 30 bucks is just by showing up to work, she gets paid 30 bucks, right? And then what does the 5n represent? Yeah, then she makes $5 for every survey. So it's in her own benefit to actually do surveys, right? Otherwise, she only gets paid 30 bucks. Make sense? So describe the function. When she shows up, she gets $30, but for every survey, she gets an additional So just something like that you can write. Remember, describe means you need to use words. So write the equation using function notation. So we're going to write it so it looks like the C of n thing. So does anybody think they know what I would write? It's not that hard. P of n equals 5n plus 30. Now you can only write it as functional notation if it is a function. So if it's not written as, if it's written, sorry, I should say it this way. If I write it in functional notation, that means it's passed the function test. And you might ask yourself, well, is this a function? Well, if I do 0 surveys, I know how much I get paid for sure. If I do 5 surveys, I know how much like, do you see it works? The function works, right? So again, I cannot write this unless it is a function, okay? So it's saying find the value of P of 8. So what would P of 8 mean? 8 is the input. It's going to go in for number of surveys. So this would be 5 times 8 plus 30. Does everybody see what's going on here? I'm replacing the 8 with the n. So that would be 40 plus 30, which gives me 70, and that would be $70. What does this number represent? Carmen's pay, right? Carmen got paid $70 for 8 surveys. Make sense? Any questions? No? So far so good? Okay, so this says now, find the value of n when P of n equals 90. So what does the 90 represent? How much she made? Yeah, she made $90, and we have to figure out what? How many surveys she did. So where's the 90 going in this equation up here? 90 is going in for P of n. Do you see that? So 90 equals 5n plus 30. Subtract 30, I get 60 equals 5n. We're not in grade 9 anymore. You don't have to show me that you're subtracting both sides. You can just do it. Okay? Divide by 5. What does n equal? 12. What does that number represent? Yeah. Carmen did 12 surveys to get paid $90. Make sense? So it's just interpreting what the equation is versus what they're given there. Okay, so then we have the equation C equals 23n plus 550 represents the cost of a banquet when n people attend. Describe the function. So can anybody describe it for me? Kind of look at how I described the survey question there, right? This is a scenario just like, I don't know if anybody's rode in a taxi. As soon as you sit in the taxi, you get charged money. You didn't even go anywhere, right? And then for every kilometer afterwards, you get charged. So what happens, how can I describe this function here for the banquet? Sorry, Sam? Yeah. So a banquet costs $550 plus $23 per person. So if nobody attends, it still costs $550. All right, so can you write it in function notation? Huh? Okay, so write in function notation. So this would be C of n equals 23n plus 550. So 550, how much is the startup fee, basically? And then it's $23 per person. So when they ask you to describe it, you're supposed to describe this scenario, right? Okay, C of 100. So how would I figure out C of 100? Well, I have to put 100 in for n. So it's going to be 23 times 100 plus 550. And you're allowed to use a calculator here. I'm sorry, how much? 2,850? Okay, can anybody verify that? Looks good to me, but I want somebody to verify. Okay, so again, make sure you put your money dollar value there. And explain what this represents. So what is $2,850? Yeah, this cost of the banquet with 100 people attending, right? Make sense? Okay, so now we're going to find n if C of n equals 4,000. So what do we do with the 4,000? We put 4,000 in for C of n. So 4,000 equals 23n plus 550. So now I'm going to subtract the 550. Again, you don't have to show each step. You can. So 4,000 subtract 550 is 3,450 equals 23n. And n equals 150. And what does this number represent, 150? Yeah, this is people who attended the banquet. What values of n do not make sense as possible domain values? Anybody tell me a number that wouldn't make sense? Yes, negatives and decimals. So negative or decimal. I'll just say partial n's. Does that make sense? So you can't have 1.2 people, right? And you can't have negative people. So remember that when they're asking you domain and range questions, right? The domain would be 0, 1, 2, 3, 4. There's not going to be numbers in between, and there's not going to be negative numbers, right? Okay, for the function f of x equals 3x minus 4, write as a two-variable equation. So I have a poster at the back. It's the orange poster at the back that says function notation is just a fancy way of writing y. So when you see f of x, that's just a fancy name for y. G of x, fancy name for y. H of x, fancy name for y. But what does this the special notation mean? It has passed the function test, right? It is a function. That's all that it's about, right? So I could have y equals something or other, but until I write it as f of x, then it's not necessarily a function, right? Okay? So how would I write this as a two-variable equation? Yeah. Y equals 3x minus 4. Not very hard, hey? Okay, so now we need to find f of 6, f of 4, f of minus 2. So I'm just going to write that out. Okay, so what does that mean? 6 is going in for the input. Then I have to multiply it by 3 and subtract 4 to it. So what would f of 6 be? Did everybody get 14? I'll repeat how I got that. 6 goes in for the input. 3 times 6 is 18. 18 minus 4 gives me 14. Yes? Okay, I'll give you a second to do f of 4 and f of minus 2 then. All right, what'd you get for f of 4? 8. And what'd you get for f of negative 2? Negative 10. Everybody got those for their values? Any questions how I got those? No? Okay. So then last question here is determine the value of x for f of x equals 2 and for f of x equals negative 1. So this is like two separate questions, right? So where am I putting 2 into this equation here? Anybody? Where am I putting 2? That's going for the output, right? So I'm going to have 2 equals 3x minus 4. Does that make sense? See what I'm doing? Yeah? Okay. I'm going to move the 4 over. I get 6 equals 3x. So x equals 2. So for the next one, I'm going to put negative 1 equal to 3x minus 4. I'm going to move the 4 over. So what do I get on the left side? 3. So x equals 1. Okay, any questions there?